Today, what I'd like to show you, and this hopefully is going to be pretty easy, is I want to remind you how to get the equation for a linear graph. So, if you could start out with a graph like this. I went out and measured the water level in my wheelbarrow every once in a while during a recent rainstorm, and I plotted out my data on this graph. I then drew in my best fit straight line. You don't want to connect the points. You want to draw your best line where some of the points are above and some of the points are below, where it goes through as best you can so that you have equal amount above and below your line. Okay, so now we want to find the slope of this thing. So, don't use data points. That's rule number one. Use your best fit line and pick out points on that line that seem to be easy to read. So it looks to me like there is a real easy point about right here where it crosses both lines. So we have 10 millimeters and we have about 8 minutes. Notice, since this is 10, this would be 2, 4, 6, 8, 10. You gotta figure out how much each little line is worth. Don't just do rise over run like in math class, because the blocks are worth different amounts. So you write your ordered pair, and that would be 8, 10. Remember, it's x, y. Then you find your next point that seems to be really good, and this one looks good, and that's about 44. Again, they're each worth 2, so that's 42, 44. And then I go across, and this would be about 22. Okay, so I have my 2 points. In order to get the equation, you need 2 points. Again, not data points, but points on the line. Okay, then you want to do slope equals change in y over change in x. If you prefer, you might remember from your math class writing it as y2 minus y1 over x2 minus x1. So y2 would be 22. y1 would be 10, x2 would be 44, and x1 would be 8. So up top we have 12, and down the bottom we have 36. Okay? So once you have that, you then want to use your calculator. I don't want you to write it as a fraction. And we get 0.333. If you're thinking about the units, it would be millimeters per minute. So the water level is rising in my wheelbarrow at about 0.33 millimeters each minute. That is not done yet though. So then you want to go back to your equation, y equals mx plus b. You then pick either point, 0.2 or 0.1, and fill your numbers in. I'm going to use 0.1, it seems like it'll be a little easier. So I do 10, that's my y value. My slope, 0.333. My x value is 8 plus b. So this is how you find your y-intercept. Don't just eyeball it, that won't be accurate. Okay? Actually plug your numbers back in and solve for b. So again, use your calculator, and I get around 7.34. Okay, what is that? It's b, it's my y-intercept, so that would be millimeters. That would be the amount of water that was in the wheelbarrow before it started to rain. Okay, so then we get our final equation would be y equals 0.333x plus 7.34. You don't leave it like this. You never leave y and x in there. So y is the water level. X is time. And that would be your final equation. You could then use that equation to make predictions on things that you didn't measure, or to figure out things that happened when you weren't actually measuring. So for instance, if I said, when did it hit a water level of 20? You'd put in 20 and solve for time. You then could say, what if it continued to rain for another 60 minutes? Okay, so then we put in maybe a time of 120 and figure out what the water level would be. Okay, so again, this is the process that you need to know to find the equation for a linear graph.